Go ahead, Nick.
Thank you, Michelle. As Michelle said, my name's Nick. I live in southern Pennsylvania, and I'm an entomologist by formal training. I completed 2 graduate degrees at the Pennsylvania State University, excuse me, in tree fruit pest management. So my specialty is basically deciduous tree fruit IPM. So I come at this from a very applied angle, and I work with numerous vegetable and fruit producers in southern Pennsylvania, both organic and conventional, and I do a lot of work with soil management and plant management to the extent that where we are employing intensive nutritional programs to optimize plant performance. And in some cases, I work with clients don't who even avoid using pesticides in an effort to uh, maximize the plant performance with nutrition. I don't always advocate that. In fact, I I rarely do, and never do unless the grower is committed to it and has suggested that's the route he wants to go. But having said all that, I am working to earn a CCA credential so that I have better footing to work with other clients and other cropping systems across the board and have some legitimacy when it comes to soil and plant management, and not just be uh, confined to the entomologist title that I have. And just to give you a brief background on my involvement with sap analysis, I started doing this in 2013 with one of my clients who had heard about this through the organic circles, and I recognized pretty quickly that it was a very useful tool and had potential to change the way we think about nutritional management, and really could change how crops are being produced and managed in the United States. So I've taken a very keen interest in it, and Michelle decided to hire me on to help her develop a domestic sap analysis program for our growers here. And my portion of the talk will precede Dan Davidson's. He's going to talk more about using sap analysis specifically for row crops. As I said, my background is in tree fruit vegetables, so I cannot offer you any insight into using this methodology on the sort of crops that are paying your bills, but I feel like I have enough knowledge of this method to give you some background on what it entails and what we're trying to achieve with it, and that's what Dan and I agreed I would do. And my talk is not particularly technical. I decided that would be more appropriate at a later juncture when some of the audience members here may have adopted this technology. There will be plenty of time for discussion about the details of the plant physiology and how the sap analysis describes it to us at another time. So what we're talking about right now is a rationale or a justification for considering this method as a plant testing tool as opposed to, say, tissue testing, which is, in my mind, the standard. And I personally was not involved with tissue testing as a plant analysis tool with my clients in any capacity. I came into consulting after working in the tree fruit business for several years, and had started my own business called Norden Agricultural, not knowing anything about crop advising or consulting except what I had learned in tree fruit. So I had a steep curve, and tissue testing was not part of that curve. There were some other things I needed to learn. But I'll tell you what I have learned since then. let's start with an extension agent that I know personally from Penn State, and he's probably considered the master of vegetable production within the extension system in Pennsylvania, and he works out of southern PA in my area. And basically, he's got up to 30 years experience using tissue testing and cardimeters to analyze plant nutrition and make decisions about inputs. So he's very comfortable with those methods, and he speaks on them extensively at winter meetings and at trade shows and other venues where he can work with growers directly, and he also uses them on a regular basis in his own trials. And he has for an extension agent, he has a very robust research program that he manages in a variety of crops. So we felt it was important to engage him in some trials that we wanted to do with this SAP testing, which I will cover at the end of my slideshow. The bottom line is this man is well respected among vegetable growers in southern Pennsylvania, and he has given a lot of advice to people and helped many vegetable growers in our area make a lot of money. Now let's go to a tomato grower that I work with personally to some extent. He doesn't have a consultant. He pretty much works on his own, but he does use SAP testing. And before he adopted it, he told us that he was routinely spending $1,000 or more per season for dry matter tissue testing. And he really admitted he didn't have a good understanding of what the tissue tests were telling him, and he could never make sense of the information in those tests, even though he was very meticulous about his management. Despite that, he regularly was gaining the top prices for his tomatoes in this wholesale market, and it actually is envied by a lot of tomato growers in our area, because tomatoes in southern Pennsylvania are practically around every corner. But this grower regularly has the highest priced tomatoes. Even his number twos, which would be a less desirable grade of tomato, he can sell privately for more money than some growers get for their best tomatoes. So he really knows what he's doing. But in 2013, he started doing SAP analysis and has abandoned tissue testing altogether. He won't go back, and he's not very open about what he does, but we know that he is justifying the cost of the testing. Because as the title of my slideshow says, it's a $75 test. But my personal goal, as I work with clients in CHL, is to show them that it's not just a $75 tissue test. Tissue tests in our area could be anywhere from $25 to $30. Let's go to another tomato grower that I am working with personally, and just started working with him this season. He attended a course that was put together by Nova Crop Control in 2014, about a year ago. And he also worked with a consultant who was also heavily involved in tissue and petiole sap testing, but not the extension agent I had mentioned before. Just today, this grower got his first sap analysis report, and he and I spent about 45 minutes just discussing the implications of his report and what we were hoping to learn from his experience. And he made an interesting comment to me before he even started testing that, you know, it's great if extension agents and other professionals in production know how to read tissue tests and how to grow trial plots with them. But he did say that growers really don't know how to use them, despite all the information that's been collected about tissue testing. And Why that may be is a matter of conjecture. If you ask 10 people, you probably get 10 different answers. But the fact of the matter is, for a technology that's a standard, even people who have been using it for many years don't seem to find it useful, and in some cases they're deciding that it's not worth their money anymore, and that the value in them is limited, and then that's driving some people towards SAP analysis. And I work with a rather large client who's a dealer for the SAP analysis program for Michelle, and we get that comment a lot about tissue tests not being very useful anymore, especially compared to SAP testing. Now, when you look at SAP testing versus tissue testing, there are some obvious differences in the layouts of the tests and the way the tests are conducted. But the truth is, regarding the comparison, it's not easy to find quantitative data on how these methods differ. In fact, since I've been working with this methodology for 2 years, I've only recently come across any sort of formal experimental data comparing SAP analysis that Nova Crop Control is conducting directly with tissue testing and petiole testing. And it was a study that they paid for to have one of their governmental institutes conduct for them. I'm not sure exactly how they manage their independent trial analysis projects in Europe, but there's only one study that I'm aware of that was even approaching validity from a scientific perspective that compares these methods. And in the States, since SAP analysis is so new, it hasn't been done at all. Again, I will address that briefly at the end of my presentation about how we're working to change that. But just for instance, here's one comparison that you could just make with a calculator, and that on a tissue test, if you have a difference of 0.1% on dry matter, and you convert that to parts per million, you would have an actual difference in parts per million of 1,000. And that's, a 1.1 to 1% difference probably isn't significant if you were to look at that on a statistical test, if it happened to be the difference between two treatments in a trial, for instance. But on a SAP analysis perspective, 1,000 parts per million is a substantial and often significant difference. And the SAP analysis will detect that difference in concentration in a nutrient, or between two nutrients, or between the old and young leaves of the same nutrient, which will make more sense to you as we continue. But one of the benefits that I see of SAP analysis is that sort of a difference or less can be detected in real time and in a way that's meaningful for making predictions about what may happen in the future with your crops. Now, some of you in the audience may have heard this comparison, but SAP analysis is essentially a blood test of the plant vascular system. And a tissue test, while it will include SAP contents, does not limit the value that it yields to SAP contents. And I would presume that tissue testing is largely going to represent what's in the matter of the leaf that's already been consumed and used by the leaf to build chlorophyll molecules, or to build membranes or cell walls, or organs within cellular organelles and the like. So in my mind, that limits what we can learn about what could be going on or what's available. And pursuant to that, crop health labs will offer the potential, I believe, to tell us how much nutrition is available for the plant to relocate or recirculate or recycle, especially in terms of nitrogen or a highly mobile nutrient like potassium. That definitely has the potential to tell us how and what nutrients are interacting and affecting the mutual availability of others. And one of the most intriguing aspects of this testing, which I've come to understand after putting it in the context of the corpus of plant physiological literature, is that we really may eventually have a very powerful tool for evaluating what I call total plant performance in terms of how nutrition is being reflected in some of the other metrics that are on the SAP analysis that aren't necessarily nutrient metrics. And one of the more intriguing aspects of these tests is there are measurements of nitrogenous molecules in the sap that I am sure will be able to tell us more and more about nitrogen assimilation and nitrogen use efficiency as we test more crops and gather more data in the real world situation. Briefly, it's important to understand what is going on with sap in the sense of plant physiology. And one of the topics that I've taken an interest in recently after delving into this more is the concepts of sources and sinks, which are critical considerations in plant physiology. And I liken the sap to the plant's supply chain. And the sap itself that's being tested now, Nova Crop Control doesn't tell us a lot about what they're testing. I think they like to keep a lot of the proprietary information close to the vest. They haven't really shared much with us on the details, but I suspect that the sap that's being analyzed is coming from phloem, from xylem. I believe that there's some of it that's apoplastic or symplastic, and that means the sap that's flowing through and between the plant cells, and there may be some that's cytosolic in nature, which is actually the liquid inside the cells, but I don't know for sure. When you read plant physiological literature, often the analysis of sap in the research is partitioned out by one of those categories. So what's true about, say, nitrogen in phloem or in apoplastic liquid may not always show up in a sap test, because if those fluids are intermingled, then there will be some things going on there that the sap test won't tease apart, and we don't know what's coming from phloem, what's coming from xylem, or from other sap sources. Despite that, the information we gather is still very useful, and some of it does correspond with what's in the literature. But getting back to sources and sinks, sources are mature leaves that provide photosynthates and other solutes through the phloem to sinks, which are consumers of material from the plant. And any young tissue or reproductive tissue, stem tissue or meristem, roots or tubers are considered sinks because they don't necessarily photosynthesize. And I'm really starting to believe, the more I study this, that source and sink dynamics are going to be critical to understanding the nutritional implications of these tests in the best depth and detail we can. roots and leaves are going to be sinks early in the plant's life, but as reproductive structures come online, then they become very strong sinks. And I'm quite certain that they have a huge impact on how the sap nutrients are manifesting on the test results. And one thing that is important from the in the plant, and I think we will learn is important for interpreting sap tests at some point down the road, is that phloem and xylem can communicate with each other. So what's typically thought of as xylem mobile only may not be in every situation. And I know that this is true with cole crops, with broccoli, for instance. I just found an article today describing how boron, which is normally considered immobile, is not necessarily so in the cole crop family. And that's important to know, because when we work with cole crops, we don't want to misinterpret the boron data, because as you are probably aware, excessive boron can be toxic in some cropping systems, and it certainly doesn't pay to over-fertilize with a nutrient that's going to end up harming the plants if it builds up. So what we're looking at here is a diagram that's been produced by the company that does the sap testing. And Michelle, I think you can make this available to people who are interested. It's something that's it's very useful to keep handy if you are working to interpret sap tests. And I won't dwell on this extensively for the interest of time, but if you glance over it very quickly, you will see how Nova Crop Control has characterized the major nutrients that are on the test, and some of it will not be surprising to you. Although if you study the literature on nutrient movement in plants, there are some caveats to this. But generally, it's a good guide and can help you see your way through a test in a pinch. So what the SAP tests are, they have several metrics in them, and the obvious ones that you would expect to be on any agronomic test, in a sense, would be the macronutrients, micronutrients, the six major ones here being boron, copper, iron, manganese, molybdenum, and zinc, and then some measurements of what I call plant performance indicators, which, if studied carefully with plant physiology in mind, can give you a very crude estimate of how the plant is using the nutrients available to it. And I put nitrogen in here, these different nitrogen categories, because they, as you know, will have an impact on each other and on the nitrogen assimilation and on amino acids and other measurements of nitrogen in the plant. Percent sugar, pH, and electrical conductivity are values that typically are pretty stable across cropping systems and across testing dates and regions, but depending on the cropping, the crop family, they can differ pretty significantly between families based on how plants respond to soil moisture, or to fertilizers, or to radiant light and what have you. And in some cases, the crop plants will just have some might be mostly sucrose in their sap, but cucurbits, for instance, have what are called sugar alcohols, which have properties that are very different from sucrose, and that can impact how the percentage of sugars show up on a test result. And then Nova Crop Control also includes what are considered beneficial nutrients and what I call ionic influencers, because they are part of the overall ionic complement in the sap and can affect the electrical conductivity and certain certain interpretations of that value can lead you to uh, parse out where ions might be out of balance, and that can be helpful for management purposes. So let's look at a test. This is an example of a test for tomato plants, and the nutrient categories are on the left-hand side, along with the concentrations there in the middle. And the red area right now shows what is considered a low level. This is true for any cropping system. This column represents low. The middle column represents what's considered adequate or sufficient, and the right-hand column represents what is considered high. Now, low doesn't necessarily mean deficient in all cases, and high doesn't necessarily mean toxic in all cases. Now, on this particular example, the boron levels, if you look down about 3/4 of the way to the bottom, you'll see boron is over 12 parts per million in the bottom line, and I'll explain what that means right here. I'm getting ahead of myself, my apologies, but let's look at what we're actually looking at here. Okay, we're going to isolate the cations, potassium, calcium, and magnesium, and the potassium to calcium ratio, which is very important in tomato cropping for a number of reasons. But what we are looking at here is, in any of these sap tests, the top green line is representing young sap contents, and the bottom dark green line is representing old sap contents. And if they're in the middle column, they're considered sufficient and adequate for that particular crop based on standards that have been developed by Nova Crop Control. So in this particular example, the potassium is slightly low in the young sap and adequate in the old sap, and the calcium is almost the same, although there's a little bit more of it in the young sap, and magnesium is adequate in both old and young sap. And incidentally, with our cropping systems in Pennsylvania, we typically see less calcium in the young sap because it's not mobile in phloem, so the upper parts of the plant can only receive what the xylem carries to them, and that's highly dependent on the transpiration stream and the moisture levels in the soil and the amount of calcium that's in the soil solution. But typically that doesn't vary much with our cropping systems here in Pennsylvania. So what we look for on fruiting vegetables, for instance, is to have more of a nutrient in the young or in the old sap than in the young, because the old sap and old leaves can supply the younger parts of the plant by remobilizing nutrients through phloem. And for tomato plants in particular, we look for a potassium to calcium ratio of 1. In this particular case, it's pretty close to that, so we would consider this balanced, quote unquote. And the goal of the grower would be to maintain that through his input. So again, the potassium levels are higher in the old sap, which is desirable, although they could be better in the young. There might be, I can't explain why they're not more, why they aren't more equal, so to speak. This grower might consider adding potassium to boost the levels in the younger parts of the plant. For some reason, the plant may not be moving it efficiently, although I don't know why. We see that the magnesium is where we would like to see it, and so is the potassium to calcium ratio, as I mentioned. Now, the one caveat I'll make with any of these tests is that we absolutely don't have any idea what precisely is going on with the plants, so we can only speculate and make decisions based on that. Now, Dan raised an interesting question about this slide. He said that when we were going over this, he said, well, that's fine. You have a nice uh, series of data points there over time for potassium showing that it's higher in the old sap versus the young sap, which is desirable. And the red bars represent the lower and upper thresholds for potassium according to Nova Crop Control's estimates. And he said, well, an educated agronomist would say, well, who says that those standards are valid? That's a good question. And the answer is we can only rely on what they've given us, but we'd like to do trials in the upcoming field seasons to establish our own validations for these standards and determine if they are in fact uh, what we can expect to see here. And ideally, we would engage some university researchers or some independent researchers to help us determine that. Now, the Jolly Elf is a cherry tomato. This particular grower was growing these tomatoes for a fresh wholesale market and had a very large crop last year, but it's a variety that bears very well. Despite that, though, he still has to manage the nutrition properly. And here is the calcium breakout. And this is, as I said, not unusual to see higher calcium in the old parts of the old leaves, and lower calcium in the young regions because of the immobility of calcium. But even though it's lower in the young leaves, there's still plenty there in both old and young to fit within the standards established by Nova Crop Control. So the grower's goal was to maintain that over time by managing his calcium input accordingly, making a rough prediction of where it would go if he added or didn't add calcium. Now, we'll look at some nitrogen metrics here quickly. Now, again, these are standards that have been established in Europe, and they recommend that ammonium levels not be greater than 100 parts per million, that nitrate levels be in the low or optimal range, and that total nitrogen, which is an estimate of ammonium, nitrate, and processed or converted nitrogen, which would include amino acids, polypeptides, and other nitrogenous molecules, that be in the optimal range. Now, with this in mind, I must say that I've seen ammonium values across the board greater than 100 parts per million, less, sometimes many hundreds of times greater. I've seen nitrate levels that are very low, and I've seen some that have gotten up into the hundreds. And I see total nitrogen levels across the board as well. And I must say that I've never seen or had a complaint of ammonium toxicity symptoms on any plants where a sap test showed that they had more than 100 parts per million in the sap. I mean, in a nutshell, I think ammonium is a critical nitrogenous molecule in a plant that can result from several different processes, and I don't think it's something that should be a concern unless there's a reason to think that it might be based on management or past history. And according to this standard, though, this particular sap test has very acceptable ammonium levels, nitrate levels that are also acceptable, and total nitrogen, which is indicating a very good conversion rate, or at least not an overabundance of nitrogen that's not being used. And I might add at this point that there are implications for insect management with these nitrogen values, but that's not a topic I can get into now just for lack of time. We'll briefly talk about some anions now, the most important ones being sulfur and phosphorus. And usually what we see in our soils in our plants is more phosphorus in the older sap and less in the younger sap, which is That's not unexpected, considering that sulfur is not a particularly mobile nutrient either. And because our soils in Pennsylvania tend to be low in phosphorus that's available to the plants, and because of our growing conditions, the plants often have difficulty acquiring phosphorus. We typically see more phosphorus in the young parts of the plant than in the old, which suggests that there's a lot of phosphorus being remobilized from sources to sinks because it's not being taken up by the root system. And that's how we can interpret phosphorus results, because we have a good deal of understanding about phosphorus availability, but for other nutrients that aren't quite as mobile, it's not always as easy to make the interpretations. When you think of sap as uh, a transportation, something that can transport nutrients, then questions arise such as, well, if it's high, if a nutrient is high, does that mean the plant has enough and the sap is carrying it because the cells don't need it? Or does that mean that it's really deficient and it's being carried in a constant stream and being consumed so quickly that it's just constantly there being used by the cells? Those are questions we can't necessarily answer, but reading about plant physiology, I feel, can help me gain insight on what possibly might be happening, at least to interpret a test and make some sense out of it so I can make a recommendation to a grower. As I mentioned, phosphorus is highly mobile, and as I also said, it's low in our soils. But what's recommended from Nova Crop Control is a value greater than 200 parts per million. So in this particular case, the quantity is there. The total amount that they want to see is present in each of the young and old sap, but it's clear that the plant is really relying on its stores and what it has to supply itself. So feeding it would probably be a good idea in this case, so that those levels don't decline to the point where they're approaching deficiency. And I put a red X there because that's a warning sign when I see that we should be paying attention to amending phosphorus in this case, and in any case where you see this, because we know how phosphorus and plants behave in our soil systems here in southern PA. And again, there's a chart showing that despite the difficulties of getting phosphorus into plants, that this grower had sufficient levels in his young leaves, indicating that the plant was supplying itself, but that it was at some points running into potentially deficient situation. So one of his goals this year is to keep feeding phosphorus to his plants, or making it available through managing his soil, to keep it higher in both old and young sap. Now, micronutrients they vary in their mobility, and we find in general that they tend to be low because of our soil pHs. And generally, we recommend that growers add them in either as packages or as standalone products. And in tomato plants, boron should be below 12 parts per million to prevent toxicity, which this is, at least in the young parts of the plant, and it's sufficient, well sufficient, and that's what you would want to see for flowering tomatoes. They require quite a bit of boron, but it is building up in the older parts of the plant, and that may be because it's not being consumed by flowers in the older parts and it's accumulating. But these plants didn't show any signs of toxicity, so it's safe to say that it wasn't at that level in these particular plants. Manganese has implications for disease management and has some other important roles in the plant. And uh, for tomatoes, it's recommended to be at least 15 parts per million. So it's obvious here that it was deficient in the young parts of the plant, which could be easily addressed by adding it to the drip lines or through foliar spraying. And we find that plants respond very well to micronutrient input. So really haven't we don't dwell on them too much, other than to say that you should increase them, and once they have reached a level that's considered sufficient, the applications can stop, and then we watch how the SAP tests change over time to determine if more inputs are needed. Uh, Pardon me, I needed to have some water. So the sampling protocols is very cut and dried. This is if anyone is interested in pursuing SAP analysis, this is the process. Consultants must pre-order labels with Michelle's office, and she provides the order forms and the instructions for that. And you provide some basic identifying information, and once that's submitted, the lab in the Netherlands will enter that information into a database and provide you pre-printed labels, which will be sent to you from Ohio, and they look like this. There will be, for every sample you take, there will be one label for your young leaves and one label for your old leaves, and each crop has a specific sampling protocol, which Michelle will provide, and those leaves would be packaged into Ziploc bags, and the labels affixed to the bags. And then once that's completed, the bags must be sent to either the Netherlands directly or to crop health labs to be shipped with other samples to the Netherlands. And they are receiving samples from all over the country, and they ship 2 days a week because of the logistics of getting the samples overseas in a timely manner. They have to ship on Tuesday or Friday, and those details can be worked out with Michelle at the time of the purchase of the sampling kits. Generally, the lab would like to see samples collected before 9 a.m., although Dan and I have questioned that, and for now we're sticking with that protocol. I think the main thing to remember is that regardless of when you sample, it should be done at the same time every time you sample to make a consistent time series of samples every 2 weeks. And we recommend collecting samples every 2 weeks so that there's enough time to make corrective action and enough time to turn around the results. Now, once the lab receives the results, they will email them back to the email address specified on the order form within 48 hours of their receiving the samples. So once they have the samples in hand, the results come very quickly, and it's for our growers, it has always been in a timely manner so that they can make decisions that impact their input. And we have not had a problem with that aspect of the process once the test results are back. Okay, so I'm just about done here, trying to stay on time, and to give you some confidence that we are working to establish a more scientific underpinning for this methodology here in the States. We have a few trials lined up that I'm personally involved with, and that Dan is also. One of them is a collaboration I'm doing with 2 Penn State researchers to compare SAP analysis with tissue testing in apples and tomatoes. And I'm also running a small trial on my own that I've financed to develop some statistical methodology to compare SAP test results with tissue test results, because to this point there isn't anything available, and that's an important piece of this puzzle for using these methods on a broader sense to understand, experimental situations with, say, insect pressure or disease pressure or something else related to a stress on the plant or an input. Now, Dan is personally involved with working out some calibration curves to make a relationship between the SAP analysis and the tissue testing against which field data can be validated. And I would like to help him with this effort, and that's something he and I are going to discuss more. And then I'm personally interested in looking at how SAP analysis results differ according to diurnal cycles in plants or soil moisture or other aspects of the management, and this is something Dan and I have also talked about would be very valuable. And these questions have arisen because in Europe, where these methods were developed, to my knowledge, they don't have an extension system. And the university researchers operate very independently of what commercial growers are doing. And to my knowledge, at least in tree fruit, there's really not much interaction between commercial growers and university people. Not the way we have that interaction here in the United States, and in certain regions of the U.S. it's very robust thanks to the land grant mission. But Europe doesn't have a land grant mission. So many of these novel technologies are developed outside of any sort of independent testing regimens. They're developed without unbiased third parties examining them. So in our agricultural situation in the States, think of the Big Six when they want to roll out a new compound or a new treatment. They will engage the universities, they'll engage extension, and they will engage independent researchers and contract researchers to evaluate their compounds in field settings and in lab settings. And that's a very valuable part of the adoption process of new technologies and new compounds in American agriculture, which doesn't exist in Europe. And I suspect that that's why Nova Crop Control has collected thousands of samples, but there's nothing verifying or validating it independently outside of what they've done. So while their data are legitimate and they're valid in the terms of what they show us about their plant systems, there's not a body of evidence that we can take to the influential people here in the States and say this is what we know about this technique that's not coming from the people who make it. And that's something that we would like to address, but we have only begun doing this year in terms of the broad adoption throughout the country. So it's a long road, but Dan and I are trying to take some steps to address it, and I know Michelle is also working with other researchers to show them that this does have a fit with the management systems that are already in place in the United States. And I'm very optimistic that once they start working with it, they will see the same. And actually, the extension agent I mentioned at the beginning of my talk is doing the tomato test for us this year, and he's very enthused about it. So I think there's a lot of potential here to learn a lot about cropping systems and to put a lot of what the researchers have done in the labs and in the field trial plots into a broader context commercially. I hope I've stayed on time, Michelle, but I appreciate your attention, and I'll be glad to entertain any questions you might have. Thank you, and that concludes my prepared comments.
Thank you, Nick, for your recap and for your time and preparations. Again, I sent a chat memo out to all the participants, just a reminder, in order to ask questions of the presenters, please respond to that chat or questions menu on your toolbar in the upper right or upper left-hand corner of your screen. If you have any questions that you think about later on, please do post those. I get those updates pretty much instantaneously. All right, we're gonna break for about 5 minutes, and I'm gonna turn the screen over to Dan. Dan Davidson joins us from Iowa. So Dan, I'm screen sharing you right now.
That's actually Nebraska. Okay.
What we'll
So
do
I'm online.
Yes, you are. We're about one after the hour. Let's take a 5 minute break, and then at 5 to 6 after, Dan will have you commence.
Okay.
All right, so everyone, 5 to 6 minutes, and we'll be back online. All right, we'll go ahead and recommence with the webinar. Dan, are you all set to start?
I'm ready.
Excellent. During the break, we had 2 questions come in. I'm going to post those to Nick and Dan to attend to either now or once Dan's session is complete. But the first question is, if we're trying to push yields, should we try to achieve nutrient levels towards the higher level of the optimum? And then secondly, if we could get more information on interpreting the pH and the sugar readings.
Okay. I'll try to address these a little bit when we talk. But if I forget, bring it up at the end. Okay, I'll go ahead and start. Yeah, is that okay?
Excellent. Go right ahead, Dan.
Okay. Yes, good day, good evening. My name is Dan Davidson. I'm an agronomist. Been kind of a dirt-kicking agronomist doing various things for the last couple decades. I'm from Nebraska. Besides being an agronomist, I do some communications work, and I do some farming in Nebraska. And we have some corn and soybeans and alfalfa. No specialty crops, but corn and soybeans. So in my work, I spend a lot of time thinking about corn and soybeans. And it's interesting to listen to Nick talk before and talk about the SAP analysis and things. And I've got an understanding of this or an idea. One of my passions is soil health. So I'm very interested in soil health and how we can improve it, but I'm very interested in how you measure things related to soil health, some metrics. So if you want to have a healthy soil, biologically active, you got to have some metrics you can measure. And fortunately, in the last couple years, several tests have come along now and have been identified, like the Solbita test and the SLAN test or the Haney test or the soil health tool. Some tools like that allow you to measure the viability and the health of the soil. And I find that very, very important because when you look at the soil during the course of the season and it's how healthy it is, how active it is, you can measure these things during the season and get an idea of what's happening, right? So there are metrics, and it's maybe like, taking your heart rate or listening to your heartbeat. You can measure these things. You can check it. So as I think about the SAP test and you think about what its value is, I think of it, part as a metric, a tool you can use to measure the health of the corn plant, the soybean plant, and the alfalfa plant, and some way to measure how it's doing. So, during the course of a year, people, they prepare their ground, they put their fertilizer down, they go to a lot of effort to get the seed into the soil at the right time in the right soil conditions, so they can get the crop out of the ground. So they set the stage up throughout the season. From the day they put the seed in the ground, they protect it from infestations of weeds, insects, diseases, and maybe they foliar feed it along the way during the season when they're controlling pests. But no one ever takes any time to really ask the plant how it's doing. There's no real easy measurement to do that. There's no way to test that, right? People have used things like NDVI and these green indexes to kind of use that as a reflection of how healthy the plant is. But there's no really way to test that, right? Some people have started using bricks as a way to judge how healthy the plant is, how physiologically healthy it is. And bricks and chlorophyll meters, they will give you some of that information, just a tad bit. When you look at the SAP analysis, you're in the way you do it, it's like taking a heartbeat of your plant, essentially, every few weeks. How's the plant responding to its environment and to how you set up the situation, right? How's it responding? How's it doing? What's its heart rate? And the SAP analysis gives you a way to do a check. And the plant can tell you how active it is in terms of nutrient uptake and all that. That is an indicator of plant health. Now, one of the questions was about pH and sugars and electroconductivity, and I've been thinking about that today as Nick talked, trying to understand that, because I'm not an expert on this yet. I have some experiences last year that I want to share with you in my thinking. But I see these things like pH and EC and sugars, I see these as some good indicators of plant health. And an analogy I might use, if you want to have a healthy soil, you have to have the right pH. You got to have the right electroconductivity. It needs to be below 1. You have to have some organic matter there to feed the system. The pH has to be neutral. The sap can't be salty. You need to have a porous soil that breathes. And so these are, I refer to that as you can't have a healthy soil without having a quality soil up front. And so as long as you have a quality soil, you have a chance to have a healthy soil. Well, the same is with the plant, right? You have to, for the plant to be physiologically active, you have to make sure that you have to have sugar there. That sugar plant has to be photosynthesizing, so you have to have sugars there. It's got to have the right pH, the right salinity. So I see these three measurements, these 3 metrics, are good indicators of a healthy plant. And if those things are in that kind of sweet spot or in the optimum range, you're set up, metabolically in the plant, for it to grow and succeed. And that's very akin to having a quality soil so you can have a healthy soil. So I think that's important, that these metrics, that we look at the SAP analysis, we look at it as a set of metrics that we can use throughout the season to do a check on how the plant is doing. So how did I come by getting involved with the SAP test? I write a column for a progressive farmer called Ask Dr. Dan, and I got interested in this SAP test early last summer and was curious about it, learned a little about it, and I wrote a story. And that's available, and you can always email me or email Michelle if you'd like to get that story. But I was very curious about the technology because in my thinking, I thought this is important. This could be a game changer. So I interviewed some people and I wrote a story. And that got me really interested in SAP analysis and then doing a little testing last year to see what I thought. But I want to back up a little bit, talk about how I kind of look at soil fertility. We always think of it from a very conventional perspective. We do our soil testing for organic matter, pH, pKs, bases, micro, CEC. So we do this conventional soil testing. That has been the way we approach fertility, as long as we've been producing corn and soybeans, right? Soil testing is just a predictor of nutrients. So it predicts things, but it doesn't show you anything about how the plant's responding. It just tells you sort of what's available in the soil, so it's an indicator. And people have been doing tissue testing now for a long time. I've done my share of that. I'm looking to see what's sufficient, deficient, what's excess. And so I sort of come to realize that I don't do those tests anymore because usually they're sufficient. And I don't learn anything. I don't know what I do with this information. I don't learn anything, right? But it does measure all the plant nutrients. When the SAP analysis comes along, it measures, this new concept, measuring all these major plant nutrients that tissue testing does, adds things in like total sugars, pH, and EC, which I think are good metrics for plant metabolic health, that it's active and functioning. And then it has these potassium calcium ratio, looks at these various nitrogen components, ammonium and nitrate, chlorine, sulfur, silica, and aluminum. So it looks at all these things. So I think it's beginning to challenge us to look at our plant and its management a bit differently. And I think this is using this as a metric, sap analysis as a metric, and also as a way to measure plant health throughout the season. You know, this technology can be a game changer. So soil tests only predicts what's available in the soil. In reality, it just predicts what's on the exchange side, not what's plant available. You know, I've never been totally comfortable with this test, the soil testing, because it doesn't reflect what the plant sees. You know, our situation, we have a high pH soil, calcareous, silty clay loam. You know, our typical approach is taking for nitrogen is 1 pound per bushel, which is a pretty conservative number. And then we take appropriate nitrogen credits. Anybody that's done the Haney test, it gives you some really good numbers for credits now. I like that. You know, phosphorus and potassium, I just try to keep them at a high level. I don't like this, because of the environment and weather, you never really want to be in a limiting situation in the soil when it comes to P and K, so you can get it in the optimal range, and then you feed the crop by removal rate. That's always a safe spot to be. So that's how I've always opposed phosphorus and potassium. Nebraska, we're lucky with potassium. It's always high, so we're always in the 200s parts per million. Phosphorus, we've made an effort over the last 15 years to get our phosphorus out of the single digits up to about 20 parts per million, 25 parts per million. So we can always assure a good, reasonable corn crop. You know, sulfur, put down 1 ton of this byproduct, ProCal 40, which is a synthetic gypsum. Every 3 years, you get about 300 pounds of sulfur from that. So that's our sulfur source, and then we get the calcium as an amendment. So that's kind of the approach you take to managing corn and soybean fertility. You know, we try to keep the soil test levels high. Then when it comes to soybeans, I don't worry about it too much. And in both crops, just apply removal rates. But on tissue tests, I've always questioned this a little bit. You know, you collect samples, you dry, grind, and ash it, and they measure the total nutrient concentration. You know, that's the technique used to work as an agronomist for a soil lab. So I knew how this worked. These samples would come in. This is what you do. You know, so it measures, and as Nick said earlier, it reflects what has been consumed by the plant, right? So a certain amount of the nutrients that you measure aren't active. It's tied up in the plant and won't be available. So I've always questioned whether sufficient is really sufficient, and can it actually predict a deficiency? And I've always questioned that in my mind and felt it wasn't very reflective because it wasn't actually measuring what I call the bioactive nutrients that weren't already consumed like you see in the sap. So the sap's a different component, would be very, very bioactive. But, you know, up until this point in time, until the sap analysis came along, we didn't have any better tools. The tissue was the best tool we had to doing a reality check if our nutrient management program was working. You do a tissue test, everything probably was in the sufficiency range. You said, well, I'm doing the best I can do. Well, the sap analysis comes along as a new set of metrics, more predictive, more sensitive to the environment and how the plant's responding to the nutrient profile beneath it. I think it opens up some doors. Just like what I mentioned earlier about soil health tests, there are now metrics today that you can easily measure that make it possible to check and monitor your soil through the season and actually see change. If you do something, you can measure change. Well, the sap analysis is very sensitive to change and will pick things up in the plant that are probably more important biologically than what's already been consumed. So that's what intrigued me about doing the test, what intrigues me today is that it's measuring this bioactive component, the nutrients in the sap that are ready to be consumed, and are there enough? So last year I got into this sort of late, back in July. So I wanted to do a couple corn and soybean samples. I pulled out of northeast Nebraska. We pulled a July date, someplace around July 25th, and then I came back just over 3 weeks later, August 20th or so, and pulled another set of samples. Corn and soybeans. And corn, I took the tassel leaf, the leaf right below the tassel, and then I took the leaf below the ear leaf. Not the ear leaf, but the leaf below the ear leaf. I considered that the old tissue. And soybeans, I pulled off the top trifoliates, and then I went down into the plant, a third of the way up the plant from the bottom, and pulled trifoliates from there. And then I just went around in an area, pulled a bunch of samples, and composited them enough, gathered enough of them to make a nice sample size that I could send off to crop health labs for analysis, right? But I was very curious about this test because at the same time I had enough material, so some went off to crop health labs. I took that same material and sent it off to our Ward Labs in Kearney, Nebraska for conventional tissue analysis because I wanted to see how the two compared and what I learned from that. So my goal was to get familiar with the test, understand how it worked, collect some samples, see how it compared to tissue testing, and just to see what I learned, what I thought from this. And I found that it was very interesting. So moving forward with tissue testing, I'm just going to talk about the corn today. This is a table. You look at these are very, very standard ranges. The percent nutrient or parts per million. You get down to the micros from micros from iron, zinc, manganese, copper, boron, and molybdenum. These are on parts per million. And then you look at the macros: nitrogen, phosphorus, and potassium, calcium, magnesium, sulfur. These are all in percent. Then, of course, in corn, you could have an ear leaf value. So you take the ear leaf at silking. That's a very standard test time when you kind of see how your crops be funding. Or you could go back earlier at B3, B4 and take the whole plant and then a different set of values, right? So these are the standards people have been going by for a long time. You send it off to a lab. They'll take a number somewhere close to these numbers here. And when they do your plant analysis and they ash your tissue and they measure it, they'll give you a number, and then they typically will give you a rating or a ranking relative to what they use as a sufficiency index, right? Of course, as Nick talked about earlier, some of these nutrients are mobile, like NP and K is very mobile in the plant. Calcium is not. Magnesium is mobile to some degree, not as immobile as calcium, but not as mobile as NPK. Of course, sulfur is not very mobile. And then all the micros are not considered mobile in the plant, except for molybdenum. And so that's from a plant tissue analysis, plant nutrients, this plant mobility. These are these general assessments of mobility. And crops could vary a little bit, as Nick talked about earlier. So I'm just going to look at I did a corn field and a soybean field, and I must say in my protocol, I'll come back to this. So I live in Omaha, and the farm's up 75 miles away. So when I go up there, I never get there until I'm not there at 9 in the morning. So I thought about the sampling protocol and that protocol and what was required at 9 a.m. And I don't live there, so being there at 9 a.m. is not easy for me to do. But you think of the turgidity in plants, and you think of some diurnal cycles and how the plant functions, right? So I felt that if I couldn't do it at 9 a.m., I could do it between 6 and 7 p.m., and the plant would be turgid again after the day, and it should have some similar characteristics to 9 a.m. This is my justification for sampling in the evening, because I could go up there and do some work, then I could do my samples and then head back to Omaha, and that worked for me last year. Now, I don't know if that's the best timing, but that's how I did it last year. When you look at all the data here, this is a standard tissue analysis done by Ward Lab, NPK, calcium, magnesium, sulfur, all the micros. And, I looked at the new tissue, the old tissue, both at the early harvest date and the later harvest date in August. And it's very interesting that it wasn't a surprise that these were all sufficient. I've done these tests over the last 10, 12 years. I go out, pour samples, and do a reality check to see if anything's deficient. And so history has taught me that doing the tissue test is sort of as a general practice, was not very effective because I always saw things that were sufficient. Now, when you're diagnosing problem areas in a field and you don't know what it is, and if you got an area in a field that's substandard, tissue test, I think, is a part of that diagnostic process, but that's a different objective. You're trying to assess a problem. When you're generally assessing the effectiveness of a fertility program, history taught me that everything was always sufficient, and so what was the point of doing the test? And that's what we saw here in these two sets of samples, new versus old. Everything was sufficient, even though I found it very interesting that the magnesium was low. I wouldn't normally think about magnesium. I don't know how to interpret this right now, but the magnesium was low. I thought that was very interesting in both the new and the old tissue at both dates. According to the sufficiency threshold, magnesium was low. It's an interesting, I'm going to watch that more this year. I'm curious about this, what that means. And then I see that molybdenum down here at the bottom was also was not sufficient down here. But the tissue analysis was as I expected. They were all sufficient. And as I've said, I've kind of concluded, I don't know what the value of this is other than for a diagnostic tool. Well, this is, you saw this chart before from Nick, and he showed it with, I guess, tomatoes. This is the same kind of chart for this, just for this corn. This is a 7 to 25th sampling date. You'll notice up here that the sugars were high, pH was good, electroconductivity were good. And, I consider these all important indicators of good metabolic health. Good metabolic health, that the plant's metabolically functioning, optimally. And that's how I see these things. But what surprised me was when you look down here generally to potassium, calcium, magnesium, all the way down here to all the micros, in general, the nutrients were short, or right on the low side to just above the low side, right? Now, this is quite different than the tissue test. Now, understand that this was the low, this was the optimum, and over here on the right was the high, and these were, classifications determined by overcrop control. So based on that, the nutrient concentrations were actually pretty short. In the sap, relative to the same measurements with the tissue were always sufficient, and these were pretty short. So that was surprising to me. Now, I don't think it was surprising. I think maybe I expected to see something different here, that this type of tissue test in the sap analysis might pick something up that the tissue test could not. Nick talked about potassium to calcium ratio being greater than 1, being around 1. I don't know how to interpret that, but in both sampling dates, the potassium to calcium magnesium ratio was very high. It was much greater than 1. In this case, you'll see it's like 5.9, 4.36. It was high. I don't know what that means yet. I don't know how to manage that. He talked here calcium and magnesium ratios. The young was greater than the old, which is, this contrary to what Nick said, that calcium calcium particularly is not mobile in the plant, so it should be higher in the old tissue. But when you look at calcium and magnesium here, it was higher in the young tissue. And that was the case in both sampling dates. I'm not sure what that means yet, right? I don't know what that, there's a lot of extrapolation we'll have to learn, we'll have to learn how to extrapolate from these measurements and interpret what it's telling us about the plant. On ammonium, he talked about ammonium being less than 100. We were always over 100 in this case, right? Nitrate levels were always very low, less than 5 parts per million. Total nitrogen, which I consider, akin to N in the tissue analysis, was always sufficient. The phosphorus levels were greater than 200 parts per million, as you can see here, but in both cases, greater than 200, but pretty low in the old tissue, but it is mobile. And phosphorus and sulfur, both of them, as the young tissue, was always higher than the old tissue. But what surprised me, lastly, just taking out some high points, is boron was particularly high in the young tissue. Sometimes you hear about boron toxicity. I'm not sure what that critical threshold is in corn, but you worry about boron sometimes. Sometimes I think maybe we don't give enough attention to boron, that maybe it could be a limiting factor, but that space between what's limiting and what's toxic is very narrow. I found that interesting here, that it was a very, very high number. So that was this sampling on the 25th. And the 20th of August, it was interesting to see that, and maybe it was the time of year, right? And it could have been the time of day. If you look at total sugars in the new tissue, look, it's very, very low. Oh, excuse me. The total sugars were very low in the young tissue and high in the old tissue. It was also interesting that nutrients seem to be more sufficient, particularly in the micros. Again, this was nearly 30 days later, out in August. The plants at grain fill were already out here at a early dense stage, probably. I probably should have took the crop stage when I did the sample. I don't recall recording that. But the tissue nutrient availability in the sap analysis seemed to be much higher, or a little bit better, a little bit more consistent in the 30 days out. And maybe this is the case because the plant here is out at dense stage. A lot of things are happening in the plant. It's going in the final stages of grain fill. Things are happening. Some of the metabolism is slowing down. And so maybe the plant, through its own internal processes, are able to maintain these nutrient levels better through remobilization than it could a month earlier. I talked about calcium and magnesium ratios still being greater than run. Calcium and magnesium, the young tissue was always greater than the old tissue. Ammonium levels dropped below 100. Nitrate levels were still very, very low. And the total N was low in the young tissue. So now we're out here pulling out that tassel leaf, and all of a sudden things are starting to happen. And the total N in that young tissue now, it's not really young because that tassel leaf has been there for a long time now. So what was, like soybeans, they continue to produce trifoliates all the way up to about August 10th or 15th. That corn tassel leaf, that's been there a long time now. And it's starting to, remobilize its nutrients down back to the ear. Phosphorus level is still greater than 100, and Interesting, phosphorus, the younger was greater than the old, but in sulfur, the younger became less than the old. So I only point these things out because of some of the things that Nick had said, and some of these ratios, some of the things that are happening, try to learn what's going on. To pull through, I just pulled this over the table, quickly, easy to see. We looked at the different nutrients. It goes down to the first sampling date, that's the 25th, and I highlighted all the reds, all the areas that were not sufficient and not sufficient. So after the hyphens, the old tissue, and the before, like the Y before the slash was the young tissue. The Y stands for yes, but for the old tissue. So you notice here at this time, when the plant's pretty active, this is around post-tassel. This is going to be around in my area. This is someplace around anthesis, R1 on corn. So so the plant's very, very active. Nutrient demands are pretty much at its peak at that time. So you see that where these deficiencies occurred, pretty widespread across all the nutrients, particularly in the older tissues. There were these deficiencies all the way through, and that suggests to me that there's something happening here. Somehow something's happening. The plant's metabolically active, but there's some shortages here. The plant's starting to really take a lot of stuff out of the old tissue, probably prematurely or something, to feed that developing ear or tuber on the plant. So I never saw any of these insufficiencies with the conventional tissue test, but I saw a lot of these here with the SAP analysis, which suggests to me that it's much more sensitive to deficiencies, and how we take this information, turn it into a decision, I'm not sure yet, but it is very sensitive to deficiencies in the SAP, and this could be affecting metabolism, and ultimately will have some shortcomings on yield. When they moved over to the end of August here, the 20th, you'll see most of these are sufficient, sometimes in the high zone. So pulling the same type of tissue off similar plants in the same area of the field, because I went always to the same area, same time of day, same type of tissues, but different plants. So you see that the sufficiency levels seem to go up as the plant was maturing out. And I attribute that more to a maturing process, demand going down. So what I can kind of conclude from my experience from 2014, I found the data very intriguing. I'm still internalizing what it all means and manage a plant and its fertility program more efficiently. I do believe that it'll come out to be a good set of metrics to measuring a way to measure the plant's metabolic health. We think of plant health, we think of stay green, no stalk rotting corn, no foliar diseases, no stalk diseases. So we think of a good plant health as something staying green and strong and lasting longer. But maybe we need to look at plant health from a metabolic perspective, as also from a metabolic perspective. And I think the SAP analysis allows us to do some checks along the way and see how healthy our plant should be. But I don't know if we have all the right scales yet to say if we have a certain SAP analysis set of values. What is that? How do we turn that into kind of a plant health assessment, some kind of a score? I think there's a lot of potential. I think continue to work with it, develop some more data, develop some more understanding, and help create the analysis to set of numbers, create a decision tool that allows you to take those numbers to make some better decisions either during the season or next year. Sampling takes more planning and time. You go out and take a tissue test. They tell you to take it at this stage, this way, no matter when you do it during the day, what day, Monday, Friday, or Wednesday next week, is sort of all the same. Well, this takes more planning and time, right? The time of day is probably pretty critical. Multiple sampling dates. It's a little more work to pull samples. When you're doing 2 samples, old and new, it's a little more work to do that. It takes a little bit more coordination. Of course, the shipping right now takes a bit more coordination. Had to take it to FedEx and then get it overnighted to. So that's one of the reasons I sampled at night. I took it, and the very next morning I could take it into FedEx, and then I could overnight it to Ohio, and then overnight it to the Netherlands. So it takes some more coordination, but that's just a process one can figure out. Learning to interpret the data and then extrapolate from the data takes time. There's a learning curve there. And, in relation to corn and soybeans in the U.S. and everything, we still have some learning to do. And as we get more experience with this and understand this better in relation to growth and development metabolism of the corn and soybean plant, or wheat or alfalfa, we'll get much better at using this as a tool to improve plant performance and yield. Now, moving forward to 2015, I want to do this some more. I'm going to do a little more stringent sampling in terms of trying to do it twice a month, like twice in June, twice in July, twice in August. I really want to develop, as Nick showed, some time curves on corn and soybeans so I can really understand that well. Along the way, I want to continue to do the old and new test tissue. I'm going to focus on running up there, do it in the morning, and then I could just overnight it the same day. If I pull samples, I can get back to Omaha overnight it the same day. That's very possible. I will probably, as part of my own study and knowledge, I'll pull some soil samples underneath that at the same time. At the same area, I'm probably pull a soil sample at the same time, and also run a tissue test. I'm very curious how this kind of stacks up with Drix, which is some measure of sugar concentration in the plant sap. So I'm going to look at these things this year, develop some response curves, and just been thinking about how to use this as a metric, as an indicator of plant metabolic health. So as I think about this over the next 2 or 3 months and start doing this, ways I can figure out how to use this as a really good indicator of plant metabolic health, I'm going to really latch onto that, right? What is, it's not just about the nutrition, it's about the plant's metabolic health. So we have to interpret it in that context. That's the end of my little presentation. My experiences this year, as I said, I wanted to get familiar with it. I liked what I heard in the beginning. I think it can be a game changer. I think it's more sensitive to things than the tissue testing is. And I think when you start to do some more homework with it, use it, just work with it more. Get some more data on corn and soybeans and develop some response curves and really learn how to interpret it correctly in relation to what the crop is. So one thing I plan to do today, this year, so when I take these tissue tests, I want to do some kind of visual assessment of where the crop is at. What's the stage? What's it sort of doing at the time, right? I need to correlate this with something, right? I need to correlate the readings with something about the crop, its productivity and yield. And down the road, if one was, and it's possible I might do this year, I haven't thought about this, if one was to do treatments and then look at your nutrient treatment or fertilizer treatment and have a plan and use this along with a fertilizer treatment to see if you're picking up some differences in the plant because of how you're managing the nutrient management, and to see what that tells us, right? If it's picking that up and how you can use this as a tool. I'm going to look at this one question here. If we are trying to push higher yields, should we try to achieve nutrient levels toward the higher level of optimum? That's a very good question. I tend to look at, when I said in the beginning, I like to have P levels at 25 and K levels like at 150 to 200. That was because if you always have them in the optimal range, the upper end of the optimal range, you know that nutrient availability is greatly influenced by the weather, soil moisture, a lot of things, temperature, all influences nutrient uptake, right? So if you have nutrients in the optimal or higher range, you're at least not having a deficiency because you have nutrients in the optimal range. So when they think about plant efficiency, it would appear to me that trying to get your nutrient concentrations in the sap, keeping up in that optimal, up to the high end of the optimal range makes sense. But that requires, that the sap is reflecting the plant's ability to pull things out of the soil. So the soil should have two things about soil fertility is the soil can have a big exchangeable supply, but it has to be able to give that up. So you have to make sure that what plants see are what's soluble, what's in the soluble phase. That's typically what's readily available. So as long as you got a good solid soluble supply of nutrients in the soluble fraction, in the water fraction, you should be able to keep that in the optimal range. But what happens as the season goes on, the soil dries down, your soluble fraction goes down in the soil, so the nutrients it has to pull off the exchange complex, that's a bit tougher. That takes more energy to do that. So that optimal range, the amount in the optimal range may drop. So I think it's a good goal, but I think to achieve that goal takes a combination of supply and good soil management. And I think a healthy soil plays a real. This is Dan's view of this. So one thing I found out with having a very, very healthy soil is a healthy soil is very well buffered against what weather does to nutrient availability. So a very healthy soil that's very active, you have better nutrient availability during the season than you would have in a conventionally farmed soil where your soil health and microbial activities, kind of average. So I think you have to look at this from two perspectives. You got to have the right supply there, and you got to have a healthy soil which keeps that supply in that soluble, more active phase in the soil for the plant to pick it up, which should then keep it up at the higher end of the optimal range. Which I think, plants, like anything, when plants sense an opportunity to spurt forward with a burst of growth or big demand for vegetative growth or grain development, right? If they sense just a perfect environment, everything's just in a sweet spot, and you see a spurt of growth, you don't want anything limiting. So considering that, keeping nutrients in the upper end of the optimal scale, always make sure the plant has an ample supply available to it. So if there's an opportunity presents itself with this plant to race forward to the head of the pack, it won't be limited by not having enough nutrients available.
And I have a comment regarding the amount of a nutrient required for optimal yield. I think from my own reading, I've learned that really will depend on the cropping system and the variety, maybe, or the region. And the case in point is going back to specialty crops. This is an example I just found today in broccoli plants. If they are provided with enough boron to initiate luxury consumption, that's actually not optimal. In fact, plants that have a slight boron deficit actually have a higher quality floret. And the floret is the part of the broccoli that's kind of bumpy looking that you actually eat. So in that particular case, although boron's important for preventing the stalks of the broccoli from breaking down internally, uh, overfeeding cold crops, in that case broccoli, with boron isn't advisable. And up to this point, we were under the assumption that, well, yeah, we want to prevent hollow stem, so we're going to feed these plants boron, and as long as it's sufficient on the sap test, it's all good. Well, it's not all good, and that can even vary between varieties within broccoli. So the short answer to that question about uh, pushing yield by pushing nutrition may not always apply, and that's why I'm a very big advocate of studying the literature carefully for these different cropping situations, because as Dan showed you with corn plants, I mean, there was no input being made to those plants in late August, and they were showing sufficiencies in their sap that would indicate that they had plenty of nutrients available to them from one source or another that was probably in most cases within that population optimizing the yield for that soil and that management system. So there's a lot more that we could get into regarding what the levels indicate on a broad scale, but in that sense, with micronutrients suddenly jumping or declining. But I wanted to address the point about nutrients and yield. And I see there's another question here about chlorine, the elemental chlorine versus the chloride ion. And that's probably a question that I should let Dan field, because I know there's a difference, but I don't know what the significance is in terms of the plant consumption of that element.
What's the question now? I don't see it here. Go ahead and just ask it. Nick.
There's a question was posed that reads, is giving a reading on chlorine instead of chloride significant?
Well, plants take up chloride, right? And
Right.
and the salt is chloride, right? That's the salt. And that's what plants take up chloride, right? And that's what they take up. See, chloride, which is a salt form, or potassium chloride, they take up chloride as a salt. So, I mean, the reading is on chloride. The measuring chloride, right?
Well, actually, it's chlorine.
So they're measuring chlorine, but the plant's taking up chloride. And then the ion is chloride.
Right.
That's the ion of the plant, right? And that's
Yeah.
the plant seed. That's what exists in the plant. And when they're measuring chlorine, I can't answer that question because I don't know what they're measuring. Are they actually measuring chloride, or are they measuring something else?
Well, they actually see, another example would be they have silica reported on the test, but all the scientific literature refers to silicon in the context of the plant physiology. So I think it might be a matter of semantics on their part.
I think it's a matter of semantics. I think they're measuring chloride just like everybody else is, and silica like everybody else is, measuring Si versus and chloride. I think it's a matter of semantics and the word you're used to using, right?
Right.
So I think it's that they're going to measure what's in the plant. What's in the plant is the salt, which is chloride.
And the bottom line is, if I'm looking at a SAP analysis, I'm going to interpret the chlorine value on that result in the context of what I read in the literature about chlorine's role in plant physiology. And it actually has a very important role. It's just not needed in great quantities. But
right.
That's how I would put the two together to understand what the SAP test is telling us.
think there's a lot of learning we still have to do yet. We need, the learning curve here, understanding the nutrients in the sap related to the plant and its needs and where it's at. I think there's a lot of opportunities. I mean, with tissue testing, people say, well, do I have enough or not? And most of the time they say they're sufficient, and that's it. They don't learn anything, right? It's just kind of a metric for is a soil fertility program working, right? That's really what it is, right? They don't manage by tissue tests. It's more of a way to evaluate whether the soil fertility program is working or not, right? So I think there's a lot of things we can do with this test. That's why I believe it will change the paradigm here, because as we understand the test, understand the relation to plant metabolism and how it's developing and reproducing, I think it will give us a lot better clues about how to manage the plant.
And in regard to the other question that was posed about pH and sugars, I recently came across some information. Was it last night or the night before? I don't remember when, but it was specifically addressing how soil moisture can have a huge impact on the pH of xylem sap, which is the sap that goes from the roots up into the upper parts of the plant. That's mainly watery. It's not as rich in solutes as the phloem, but it carries a lot of ions in it that are vital for nutrition because it's coming right from the soil solution through the roots up into the plant, and it's tightly regulated with the transpiration stream of the plant. So, for instance, when the soil is rich with nitrate ions, that xylem sap tends to become alkaline. If if transpiration is very rapid, as the sap moves through the xylem, there are ATP pumps in the xylem walls that will draw out protons from the transpiration stream and make the sap more acidic. Is that how it works? I'm drawing a blank on exactly the relationship. The point is that nitrate ions influence the pH of the xylem sap, and that in turn can influence abscisic acid, which is an important hormone that has been identified as regulating stomatal conductance. So when you look at everything in context, there's a relationship between the transpiration stream, the pH of the sap, and the nutritional levels and soil moisture in the soil around the roots. And these authors, this was a peer-reviewed study, they actually developed a model that they illustrated schematically, which I think could be very valuable for us as we try to piece together what's going on with the sap tests down the road. So there's a little bit of information regarding sap pH that, put into proper context, could be something that we could put together with our sap results to understand more about the nitrogen dynamics, for instance. And there are other implications like that with sugar levels too. And I can't think of any off the top of my head, but those relationships are represented in the literature, I believe, pretty heavily, and as we uncover them, we'll start to see how we can use that information practically.
Well, Michelle, I think we're coming back to you, Michelle.
There's another question here about the older leaf sap versus younger leaf sap. What does it mean when the older leaf level is higher than the newer leaf level? And generally what that's indicating is that in the case of, say, calcium, that indicates that there's a transpiration stream that's drawing the calcium into the older leaves, and it's being it's being consumed, built into cell walls, or being put into other cellular structures, or maybe it's being used as a signaling molecule. But the bottom line is that it's not going to be remobilized from that location. Um, and that's typically what we see in the case of calcium. In the case of something like potassium or phosphorus, it indicates that there's a reserve in that old sap, in that old leaf sap, that the plant can use to supply the sinks and the younger parts of the plant that may not be provisioned from nutritional input or from foliar sprays. And we've come to understand that if it is greater in the old sap with certain mobile nutrients, that the plant has an internal supply that it can use when it's not receiving adequate nutrition from the roots. And we see that those levels start to decline more in favor of the young sap as the plant is circulating that nutrient out of its storehouses in the older sap and moving it through the old sap into the younger parts of the plant. Now, there's another question here that says address the importance of balance of nutrients, as too much of one nutrient can create a tie-up of another nutrient. And that's a good point. That's something I should have addressed in my portion of the talk, which I didn't, and that's my mistake. But here's basically what happens with, let's just take calcium, potassium, and magnesium. They're all cations, and some of them are very similar in their valences. Sodium is another cation that's very similar in valence to potassium and potassium, because they both have one electron. Their valence is 1. So if one of those nutrients, say sodium, is high in a saline situation in the soil, that can interfere with potassium uptake and distribution, although the situation has to be pretty extreme. The same can happen with chloride ions and phosphorus and sulfur, because they're anions. So ions with like charges tend to be competitive within the sap and within the soil solution and with the soil colloid positioning. One of the examples that we got early on was that if ammonium ions become too excessive, they have a valence of 1. They can interfere with calcium uptake, and I have seen that happen in tomato greenhouse plantings, where the growing medium is actually a compost that's very rich with immature organic matter and a lot of microbial activity, and there's a lot of ammonium being generated by the anaerobic conditions in the compost, and that's generating excessive ammonium ions that limit calcium uptake. And sure enough, the plants are showing the symptoms by having leaf margins on the young leaves that are brown, and stunted leaves, which is a sure sign of calcium deficiency in the young tissues. And believe me, when you see that in a 5-acre greenhouse of tomato plants that are about 1 week from blooming and setting their first fruit, it's not good. And I've seen that happen. I saw it on the sap test before I saw it on the plants. So hopefully that answers that question. Well, Michelle, I don't see any other hands, virtual hands going up, if you will.
I don't either, and I think that'll conclude this evening's webinar. I just wanted to direct everyone's attention to our website, crophealthlabs.com, We have some additional content, and also a full recording of this webinar will also be posted to our main homepage. If not later this evening, then tomorrow morning. And also, if you have any direct questions that you think of after the seminar, or you have general questions about how to order or how to access the technology, you can connect with us at Michelle, Michelle, at crophealthlabs.com, or also our phone number 800-495-7938. And if there are no further questions, I'm going to go ahead and close out the webinar for this evening. Thank you all for your time and attention, and don't hesitate to follow up with any additional questions. Have a good night.